Hey mathematicians, this is Mrs. Shopper coming with similar triangles, section 7.3. I'm doing all of the chapter 7 videos in one crack. So I'm wearing the same outfit every video. I'm just shooting them out on my days off, all right? Well, actually your days off, my days of getting work done, okay? So here we go. We're talking about similar triangles, okay? So we, just like we can prove triangles congruent, where they have the same shape, same size, same angle measurements, we can also prove triangles similar, meaning they have the same angle measurements and their sides are proportional. So what we're going to be talking about today is how do you prove triangles similar? And one of those ways is called the angle similarity. Okay, angle similarity. What that says is if two angles of one triangle are congruent to two angles of another triangle, then those two triangles are similar. Okay, then they're similar. And so because automatically the third angle is going to be the similar because the third angles theorem. If you remember that from a while ago, it says if two angles are congruent to two angles of another triangle, the third angle is congruent. They call it the third angles congruent. Third angles theorem. And so that's what we're building off of with this one. So you can prove two triangles congruent as long as you know that two corresponding angles in one triangle are congruent to two corresponding angles in the other triangle. All right, so we got to determine whether these triangles are congruent or similar, sorry. If they're similar, we're going to write the similarity statement. Now, just keep in mind, this right here is a similarity statement. Using that similar symbol and then making sure that your angles correspond. Okay, so let's go through this. So what I have here is I have E is 80, D is 42, which makes angle F 58 degrees. And the reason why I know that is because the triangle angle sum theorem says that all three angles have to equal the same measurement. And so 80 plus 42, 122, yeah, plus 58 is equal to 180. So that has to be 58 degrees. When I look at this triangle, angle A has to be 80 degrees because 42 plus 58 is 100 plus 80 gets me that 180 degrees, okay? So these two triangles are going to be similar. So now I need to write my similarity statement. Triangle BCA is similar. Okay, so B is 42 and D is 42. Here comes my highlighting again. A is 80 and E is 80. And then F and C. So here we go. So BCA, so B is to D, F, E. Here's my similarity statement. Okay. All right, let's take a look at this next one. We know that angle QXP and MXN are congruent because of the vertical angles theorem. We also know that QPM and NMX are congruent because they're alternate interior angles. And so we have two congruent angles in each triangle, so we can say that they are similar. Q and N correspond, and M and P correspond, and X and X correspond. So when I want to use my similarity, I can say triangle QPX is similar to triangle, and then this is where my highlighting really helps me out, NMX. That's my similarity statement. Okay. All right, here we go. I'm not sure what this points on perpendicular bisectors thing comes in. So we're just gonna, that's just a typo. So here we go. Side similarity. So if we have all three sides of one triangle proportional to all three sides of the other triangle, we can say that they're similar by side. So what we're saying is that you need to have corresponding lengths proportional, okay? And then you can use the side similarity. Now, when you're proving figures similar, you have to use the word similarity. Angle, angle, similarity. Side, 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 similarity. Side, angle, side, similarity. We want to make sure that you're talking similarity. And so with the congruent statement, the proving triangles congruent that we did, we said you could just use ASA or SAA, SAS or AAS, right? Never ASS, that's bad. All right, so we said you could just put that. When you're talking similarity, I need you to write the word similarity on it, okay? So what we have here then is also the side angle side similarity, okay? And that means, like they're showing in the picture, that you have two sets of sides that are going to be proportional, and the angle that it includes has to be congruent, okay? And that's how you show that your triangles are similar, okay? So angle, angle, side, 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 similarity, and side, angle, side, similarity. Okay, so now we have to determine whether these triangles are similar, and if they are similar, we have to write a similarity statement and explain our reasoning. So similarity statement, explain your reasoning. Here we go. So I know that those two angles are congruent, right? They're vertical angles. I don't know anything about parallel lines, so I can't say anything else about any other angle. I can only go with this. So now I need to see if their sides are proportional. So when I look at this, I want to see if there's some proportionality between these four sides. So if I do is AC to CB as DC is to CE. I want to see if this works, okay? So AC is 6, so I'm going to put a 6 there. And CB is 7.5. And DC is 4. And CE is 5. So I want to know, is this proportional? Okay, so 6 times 5, if I do cross products, that's 30. 4 times 7.5, that's 30. So that works. So I can say that triangle ABC is similar to triangle. Okay, so now I got to get my highlighting back on. We're going to erase this. Okay, so AC this isn't going to work because I took them from the same triangle. Let's try this again. Let's try AC to CD and BC to CE. So AC is 6, CD is 4, BC is 7.5, and CE is 5. So what I need to do is make sure I'm pulling one from one triangle, one from the other. What I did initially is I pulled them both from the same triangle, and that doesn't work. Okay, so 30. Okay, so this works. So AC corresponds to CD. So I need to make that this color. Those are corresponding sides. And then I see that 7.5 corresponds, so those two correspond, which would make then these two correspond. Okay, so triangle ABC is congruent to ABC. So DEC. That's my triangle similarity statement. Okay, so it takes a little trial and error, helps you a little bit. Let's look at this next one. All right, so I'm going to redraw these triangles. I have M, N, and P, and I have M, R, and S. And when I look at these triangles, I know that angle M is congruent to angle M. M is congruent to M because they're the same angle, right? Reflexive, property that we've talked about, same angle. So now I need to see, is MN proportional to MR? So MN is 10, where MR is 25, and MP is 12, and MS is 30. Okay, so is 10 to 25 as 12 is to 30. Okay, so 10 times 30 is 300. 12 times 25 is 300. So they are proportional, okay? And so when I go to my highlighting piece, I've got that MR is proportional to MN, and I have that MS is proportional to MP. So I can use angle, side, angle, similarity. So my statement is going to be triangle MNP is similar to triangle MRS. And there we go. Properties of similarity. These are all properties you've heard of before: reflexive, symmetric, transitive. Make sure you get those down on your note cards. All right, here we go. Given that RS is parallel to UT and RQ is x plus 3, QT is 2x plus 10, find RQ and QT. Okay, so these two sides correspond, and these two angles are congruent because they're alternate interior angles. Is it coming? Come on. It'll be there soon. And then we can say that these two sides right here are proportional. So we can say that 4 is to 10 as x plus 3 is to 2x plus 10. And then we do cross products. So 8x plus 40 is equal to 10x plus 3. So 2x is equal to 37. So x is equal to 18.5. So RQ, let's see if I set that up right. 4 is to 10. So x plus 3 is 10x plus 30. There's my mistake. Sometimes you just have to double check. This should be 10, which means x equals 5. All right, so RQ is 8, and the measurement, there we go, and the measurement of QT is 20. All right. All right, so this is just kind of a review of the 3 ways that we talked about proving triangles similar. Okay. All right, got one more problem. Let's do this. Brecken wanted to measure the height of the Sears Tower in Chicago. He used a 12-foot light pole and measured it. So what we're doing is we're setting up our proportion, right? We're saying the height of the light pole is to the distance Brecken is from the light pole, and the height of the building is the distance that Brecken is from the building. And so what we're going to do is we're going to do, let me pull up my thing. So 242 times 12 divided by 2, x is equal to 1,452 feet. Okay, that's how tall it is. So here's your work. Nice job today. I look forward to seeing you soon. Take care, y'all. Bye-bye.